Hi everyone, good afternoon to everyone. I am Sai Manikanta. I am going to explain about the error detection and correction in data link layer. Before going to explain, we have to know what is error. When bits are transmitted over the computer network, they are subject to get corrupted due to interference and network problems. The corrupted bits leads to spurious data being received by the destination and are called errors. Types of errors: single bit error, multiple bits error, burst error. Single bit error: in the received frame only one bit has been corrupted, that is either changed from 0 to 1 or from 1 to 0. Multiple bits: in the received frame more than one bits are corrupted. Burst error: in the received frame, as shown in before, single bit error, in the received frame only one bit has been corrupted, but in burst error more than one consecutive bits are corrupted. Control error: error control can be done in two ways: error detection and error correction. Error detection involves checking whether any error has occurred or not. The number of error bits and the type of error does not matter. Error correction involves ascertaining the exact number of bits that has been corrupted and the location of the corrupted bits. For both error detection and error correction, the sender needs to send some additional bits along with the data bits. The receiver performs necessary checks based upon the additional redundant bits. If it finds that the data is free from errors, it moves redundant bits before passing the message to the upper layers. Error detection techniques. There are three main techniques for detecting errors in frames: parity check, checksum, and cyclic redundancy check. Parity check. The parity check is done by adding an extra bit called parity bit to the data to make a number of ones, either even in case of even parity or in case of odd parity. While creating a frame, the sender counts the number of ones in it and adds the parity bit in the following way. In case of even parity, if a number of ones is even, then parity bit value is 0. If the number of ones is odd, then parity bit value is 1. In case of odd parity, if a number of ones is odd, then parity bit value is 0. In case of even parity, the given number of ones is even, then parity bit value is 0. But it is in odd parity, number of ones is odd, then parity bit value is 0. If a number of 1 is even, then the parity bit value on receiving a frame, the receiver counts the number of ones in it. In case of even parity check, if the count 1 is even, the frame is accepted, otherwise it is rejected. A similar rule is adopted for odd parity check. On receiving a frame, the receiver counts the number of ones in it. In case of even parity check, if the count of ones is even, the frame is accepted, otherwise it is rejected. A similar rule is adopted for two odd parity checks. The parity check is suitable for single bit error detection only. Checksum. In this error detection scheme, the following procedure is applied. Data is divided into fixed sized frames or segments. The sender adds the segments using ones complement arithmetic to get the sum. If then complements this sum to get the checksum and sends it along with the data frames. The receiver adds incoming segments along with the checksum using one's complement arithmetic to get the sum and then complements it. If the result is 0, the received frames are accepted, otherwise they are discarded. Cyclic redundancy check. Cyclic redundancy check involves binary division of the data bits being sent by a predetermined divisor agreed upon by the communication system. The divisor is generated using polynomials. Cyclic redundancy check involves binary division of the data bits being sent by a predetermined divisor agreed upon by the communication system. The divisor is generated using polynomials. The receiver divides the incoming data unit by the divisor. If there is no remainder, the data unit is assumed to be correct and is accepted. Otherwise, it is understood that the data is corrected and is therefore rejected. Error correction techniques. Error correction techniques find out the exact number of bits that have been corrupted and as well as their locations. There are two principal ways. Backward error correction, that means retransmission. If the receiver detects an error in the incoming frame, it requests the sender to retransmit the frame. It is relatively simple technique, but it can be efficiently used only where transmitting is not expensive as in fiber optics and the time for transmission is low relative to the requirements of the application. Forward error correction. If the receiver detects some error in incoming frame, it executes error correction code that generates the actual frame. This saves bandwidth required for retransmission. It is unavoidable in real-time systems. However, if there are too many errors, the errors need to be retransmitted. The four main correction codes are Hamming codes, binary convolution code, Reed-Solomon code, low density parity check code. Thank you. Made by Y. Sai Manikanta.